ourselves. So physical product design. We're going to talk a little bit about the theme of 3D printing, but not sort of go to the mechanics or anything like that. So if you're expecting to be nerded out about that, this isn't the talk. But hopefully there's another one of those so I can go into that. So who are we? My name is Amy Wagner, and I work 3 days a week for the Ministry of Justice in London. I'm from Melbourne, originally Melbourne, Australia. I also work on my own startup called Hookline. That's a music publishing company, so something entirely different. And I come from a front-end development background. And this is...
My name is Emily Webber. I am an independent Agile coach, ex-GDS. I see some of my ex-colleagues in the audience. I work across government and private sector stuff. I come from a maker background as well. I went to art college for 6 years, which obviously is a standard route for any Agile coach. Went through kind of music and tour management, some of that kind of stuff, and ended up in kind of digital and Agile world.
Fun. And we've actually been working together for years. So we go way back to when we were at an agency called Headshift in London together, working as project managers. And and as most ideas, particularly my world, it started over wide, and we came up with this concept of the minimum viable book. And we did a little quick domain name search, and no one had registered minimumviablebook.com, so we thought it was like our responsibility to register that at that point in time and do something with this concept of minimum viable book.
And most domain names registered over one, I'm sure.
I think so. I think so. So the themes that we're going to discuss today, there's like 3 stories from people that we've been talking to while researching what the minimum viable book is, and we're still understanding. This is sort of our current understanding of what the minimum viable book is at the moment. It's stories inspired by people who make things happen. So inventors, creators, builders, learners, strivers, doers, and we just say dive-right-in-ers. And a lot of the people that we talk to have never even heard the word Agile before, or maybe go, yeah, I kind of know it, but they're just getting into it, and they're getting stuff done, and they're making stuff. And I really love that concept. And here's a few of the people that we've been talking to. Emily, I'm not going to say her last name. She sent me a challenge to say Jane from Sugru, big person up here. Her last name is Nicole Quintic. Yeah, okay, so and so the inventor of Sugru, we've got Henry Wolf here. She's this one here. She's the inventor of the Makehead Austin Tinkering School. That's it. Austin Tinkering School in Austin, Texas. And she was really inspired by a person called Golda Tully. Who wrote a book called 50 Dangerous Things Kids Should Do. And she really wanted to get that up and running in Austin, and she really wanted someone to do it until eventually she was like, well, I'll just do it. So we spoke to her when we were in Austin. We've spoken to quite a few people in Berlin, Bristol, all around the UK.
And if you want an excuse to go and talk to people you find interesting, when you say, hey, we're writing a book, can we chat to you for an hour over coffee? Everyone's like, yeah, that's great. You get really inspired by people.
You do, and you don't even have to write the book, which is an added bonus. So here's some of the people, so I'm going to pick out 3 of them today and talk around the theme of 3D printing and how that's changing your world. So before we get on to that, what are our typical constraints with physical product development? There's 3 that I'll pick out. It's quite a lot. It's so much more difficult than software. First of all, the cost of change. It's extremely high sometimes. So particularly like say you're building a shard, halfway through the shard, you go, oh, I just want 5 meters to the left. It's so expensive to make that change. Or if I don't want to build it in glass, I want to build it in floorboards. It's going to be super expensive to change, and we don't usually have that constraint in software development. So it can help us be agile. We also come across this like economies of scale issue. It's really, really expensive to make bespoke one-off things if you're trying to build a pencil factory 10,000 pencils of a single variety. It's a lot cheaper, a lot more easier to manufacture. And we also have this other issue of human safety, this burden of keeping people alive. So obviously, if you're shooting a rocket to the moon, you really don't want to make that your first test with a human inside. Same with toys for children. You want to make sure that the material that you're using is safe if they accidentally swallow it or put it in their mouths like they do. So 3 things that we'll sort of cover during the rest of the event.
Okay, so we've got 3 case studies that we're going to go over, and I am going to start with this one about how 3D printing is disrupting the toy industry. So, to do that, I'm going to start to talk about a company called Mattel. Has anyone here not heard of Mattel? Yeah, pretty big, huh? So they're American. They were founded in 1945, and they have headquarters in California. In 2004, they ranked 403 on the Fortune 500. They have a bunch of brands as well. And they are big. This is from their annual report from 2013, $7.1 billion worth of revenue. Mostly in North America, some in Europe, some in Latin America, Asia Pacific. And the chart on the left is some of the brands that they cover as well. So they're big, and they're biggest in the States. They have a number of competitors as well, but they've got a big chunk of the market share. And I'm going to tell you a little bit about their production cycle, and I'm going to use this as an example. Does anyone recognise this? This character? Anyone have small children?
It's
So this is a doll that Mattel make. Maybe some of you have in your house. Factored into buying the hats for life. So this is a toy that they make, and they make it in this way. So this is Mattel's published production cycle. It's big. So it has 8 stages in it. Think of them as stages. So they start at stage 1 with ideation, and ideation also includes things like they start thinking about what websites they might have next to it, other things like that. They have a standards and practices procedure that they follow during ideation. And they have to think also very early on at this stage about the whole cycle. It's quite a long cycle, it's got huge upfront investment. They need to make sure that they're going to be able to make their money back. So then they move into design and development. So they've got their idea for their frozen doll. They move into design and development, and they have to think at this stage quite heavily about safety. This is the toy industry, these are kids. It's important that you don't choke from those kind of things. That doesn't look very good. And so they have certain standards that they need to follow at that stage as well. They move into marketing, so at this point they've got their prototypes, they can start marketing, they can start telling people what they're building. And they need to follow certain practices here. There's the Children's Advertising Review Unit. They need to make sure that the way they're advertising these toys is suitable for children. Then they move on to procurement, so buying materials that they need to make the product. Onto manufacturing, and I'll touch on that again in a moment, but that's also about managing their suppliers as well. So they need to heavily manage, make sure that they're making the right things and they're up to the right standards. And we're making these, making them in huge bulk. The distribution, which will be a ship at this point in time, they've got these huge amounts of dolls that they've made. They need to bring them back to the countries where they're being sold. They might be being sold to resellers, people. Only then, at stage 7, do they start to see any return on that investment. So they've gone through this huge cycle. I don't have dates for this. I've been trying to find out how long this takes to standard, but I haven't come to the figure yet. It's been quite a long time. And only at stage 7 do they start to see any money. And then at stage 8, things start to get out to consumers, that's to the users. So only at stage 8, after all this time and investment, do people actually get these things in their hands, and they actually able to test them out with other people. And then that cycle may go round again, so they may go round back to ideation, but it's more likely that they're going to have started on something else. So they're not really iterating on what they have. Does anyone recognise this kind of cycle? Look familiar to anyone? Anyone been on a software project that looks like this? It works really well, doesn't it? So what's really important to Mattel is that their products are of a high quality, they're well tested, and that's how they build their trust with their consumers. Actually, it doesn't cost that much to make that doll. That doll doesn't cost very much at all. It's the upfront investment that costs. So once they've made the mold, they can just, churn them out. It's all fine. They put the effort into the process because they believe it makes them better. So their product development risk looks a bit like this. Again, anyone recognize this? Anyone like this? So it looks a lot like waterfall. It's a big bang approach. Lots of upfront investment, then it's released. They talk about their risks as well, but they talk mainly about things like competition, legal proceedings, changes in buyer behaviour, exchange rate, political instability, and earthquakes is actually on their list of risks. So sounds. Anyone had a risk register with something like earthquakes on it? It's not. Probably not uncommon. And it's developing in this way is really risky. This toy blew my mind. Has anyone got a Barbie and Tanner Cooper Scoop doll? What's also really weird about this is she picks up the poop. It goes back in the bowl. I don't know what it's teaching children. But this was a product that was recalled, so it had recalled and reissued. But it was recalled because it had some dodgy magnets in it that were falling off, so it was dangerous to children. In 2007, they recalled 683,000 toys. So they put all this money and they've recalled all these toys.
And then they put it in landfill. So it's really great.
They spent $12 million on recalls and legal settlements in 2007 as well. So all that money is somehow being passed on to the people buying the dolls at the end. Another big risk that they have is not enough return on investment. So again, anyone recognise this picture? So they have to do things like pair up with companies like Disney. They have to know that they're going to get their money back. So there's no real innovation or excitement in what they're doing because they need to know that they're going to get their money back. So they have to do these partnership deals. So it becomes a bit dull.
It's samey.
Production locations are interesting as well. 74% of their stuff is made in China. That's over 50% of their stuff is sent to America. So that's like the furthest you can get away. So you can think about the world. And means, I won't talk about working conditions in Chinese factories, as some people do. But it means this. I always find these kind of fascinating, because those are shipping containers, that's huge. So it means that things are travelling, huge shipping containers. And yeah, if they don't sell stuff or they recall it, they're putting it into landfill. So that's the old world. Sounds a lot like some software development products for sure. This is a photo, realistic photo of a guy that I spoke to called Ben Griffiths. And Ben, this is his Twitter profile picture, by the way. We didn't just go, it looks a bit like
Oh, that's what he looks like. I think he's child doing
yeah,
that.
just doing that. So he was the CTO of Makey Labs when we spoke to him. We had this fascinating conversation with him. Has anyone heard of Makey Labs or Makey Dolls? And education. If any of you have children or like dolls, as they do have a big adult audience.
They do, yeah.
He told us the story of the doll that they're making and how this is disrupting the way that the traditional industry has been working. So this is a Makey doll. It has been around since they had a demo in June 2012. It's been it's toy safe, so it's safe for kids. It's been made since February 2013. So you can go.
It's 3D printed.
It's 3D printed. So you can go to their website. So it's software and hardware supporting each other. You can go to their website, design your own doll. Looks like send you your 3D printed doll, which will be unique and bespoke to you because it's how you want it. And so what's fascinating is their production cycle completely turned Taldo on its head. So you've got consumers at the beginning of the process, not at the end of the process. You've got consumers going onto the making website, designing the doll that they want, buying the doll up front before it's made. Then it goes to manufacturing, then it goes to delivery. And what they've done, which is fascinating, is they've taken procurement, marketing, and ideation out of that production cycle. They can do that stuff outside of the doll being created. They're not quite single piece flow. It's not you order a doll and then you get that one. Because of the way that they do their 3D printing. So it's not the thing that you might be used to with the bits of plastic, it's kind of powder based. They do 6 dolls at a time. So every 6 batches, they can actually make changes to the next lot. So if something they find doesn't work, or some limbs aren't right, or joints aren't right, they can change that in the next 6. They're mostly made in London and Amsterdam. I think the idea is that they localise around. So their development risk looks a little bit more like an Agile project. They develop stuff, they kind of build up, I guess, each 6, and then it comes down. So they've got much sort of shorter cycles. They can iterate much more quickly. They can respond to what their users need, much like an Agile project. And they can do things like create toys that are a little bit different. So they have this range called Toys Like Me, with I think this one has a hearing aid, this is a walking stick, and they can have different ways of trying stuff out, and they can do that because they've got short production runs. And Mattel just aren't able to keep up with that at all. And it's also created makers around the makeys, which is
Super freaky though.
if you Google kind of makeys and hacked makeys or customizations, there's lots of strange people out there. Let's just leave it there.
There's lots of little mini Emilys out there, which I imagine.
So this is using Arduino to try and animate the dolls. So there's created this whole kind of making industry around it, which is fascinating. But it's actually, as well, people like Mattel are starting to listen as well. So they are now trying to catch up with that and go, what can we do and how can we start doing that? So they're trying to, I think, 3D print cars towards the end of this year, I think, is the last I heard on the date of that. So it's actually, whatever happens to makeys in the future, it's turning this industry into something that was very kind of slow paced and slow moving, and making them suddenly go, okay, well there's these people nipping at our heels, what do we do? How do we make ourselves be a bit more agile? Right, over to Amy.
Sorry for the dating headline. But, I want to talk a bit about aviation, commercial aviation especially. And particularly on this point, the pace of innovation is slowing down a lot in commercial aviation. I'm going to look back a little bit at the history and what's happening now to disrupt that. And by the way, let's not use the word drone. Apparently all the cool kids are using the word UAV, and the acronym UAV, which stands for Unmanned Aerial Vehicles, removes the kind of military connotations. So let's use UAV in our one. Is anyone here from Airbus or Boeing? Carry on. Oh, they're not going to say no, are they? But, it's a little bit of a story about Airbus and Boeing and where they are right now as well, and sort of the lack of competition that we're seeing in the space. And maybe that being a kind of factor for slowing down this sort of innovation that we're seeing. One of the people we spoke to, this is actually a pop photo, this is Matthew Johnson. He's an aircraft designer and maker, and at the time when we spoke to him in Bristol, he was still working for Airbus. He's now gone alone. But he was like an aircraft designer engineer, and he was very, very passionate about this subject, very, very interested. We learned a lot from him. And his point is they're just stuck in this really slow incremental innovation cycle, but like super slow incremental. And sort of, he's like, why is this? Why is this happening? And why do they even need to change? And for some reason, there hasn't been a lot of necessity, a lot of impetus to change. But it's actually causing really catastrophic effects for the environment as well. So let's look at two models that he was talking to us about. So the A320 is an Airbus. It entered service in 1988. So the A320 is like that, that common EasyJet kind of aircraft that you get on to go to holidays in Spain or wherever. And it's super common. It gets updated a little bit, like with the kind of furnishings and that sort of thing. But since 1988, it hasn't really changed at all. So we're talking about 27 years. Now, A320, the A320neo, is the new version of that that's about to enter service this year. And what have they changed? Well, they have created a new engine. So NEO, NEO stands for New Engine Option, New Engine Option. And they also changed, they made a change to kind of the aerodynamics as well. And we see that apparently about 15% more fuel efficiency has been achieved over that time. So 27 years, and that's what they got to. And clearly this is a case of the burden of human safety, right? Because it's such a risk that everyone's so worried about harming humans in this aircraft. So a couple of figures just to put this in perspective. So this is actually the average life cycle of a single-aisle EasyJet-like passenger plane. That's across the board for that kind of model. And how much of the references, if anyone's interested in newspaper version of here. 4.7% is the forecasted increase in air traffic every year for the next 20 years. And that's stats that Airbus has published and Boeing agrees with. And actually, that's going to mean that air travel has doubled by 2030. So it's quite a lot. Okay, and this is like if we just take the A320 as an example, it basically means there is a 0.5% improvement rate every year. It's not a lot. So that's maybe okay, but this makes it even worse. Only 1.6% of a fleet gets replaced every year. So that means only this many in a fleet are improving every year. So this is pretty dire straits that we've got going on in commercial aviation. But it wasn't always like that, which is, I found the most interesting part of the conversation we had with Matthew, is that back in like the early days, this is a model from 1910. Back in the early days, people didn't know what a plane was supposed to look like. So they were like out flight testing in the morning, crashing in the afternoon, and then quickly iterating and then flight testing the next day. So they were much more agile back in the day. And the brave people getting on board that plane, well done to them. So yeah, there was lots of sort of human-powered flight competitions, lots of cool sort of things going on to drive this fun that everyone seemed to be having in aerospace at the time. And this is a quote from Matthew. He's like, the early days of aviation was like natural selection because no one knew what a plane was supposed to look like. I also made this really interesting point that if we were to design an aircraft today, it would look entirely different to the A320 because all of those early designs were happening in parallel. No electronics, no modern plastics, none of these sort of modern materials people manufacture with today. So we're really slow at this point and causing quite a bit of damage to the environment, and it's only going to get worse. So can drones save the world? Here's a model from Marvel, and Marvel is a company that Matthew left Airbus to set up. Very cool looking thing. It's actually not that big, it's about this big. inspiring workshop working on that. I'm going to read you a quote from him. In 100 years of aviation, 1.5 million planes were manufactured, and half of them were manufactured during World War II. Because there was a kind of necessity, there was a need to actually to move forward with this sort of pace of innovation. But last year alone, more than 1.6 million drones were built. That's called UAVs. UAVs were built. So this is going to change the pace of innovation in this space, because they're now finding a way of crashing flight testing, changing designs, and finding ways of doing that in a sort of safe way. And then hopefully soon there'll be leapfrogging on that, there'll be some brave humans trying their first flight tests. But he says, we finally found a way of applying the MVP philosophy to aircraft design. Quite interesting. There's a whole load of companies getting into this space. We've got Google, they've found a company recently called Titan Aerospace. And then we've got Facebook, quite a company, a UAV company. We've got Amazon famously talking about delivering their goods with drones and UAVs. It's all happening. And there's a fun quote from Elon Musk, one of my heroes. He's so fabulous. He said about Boeing, this was in 2012, Boeing just took $20 billion in 10 years to improve their efficiency of their planes by 10%. That's pretty lame. And I love that we've got these characters pushing out and saying that this is possible and we don't have to be stuck in this old way. And sort of almost bringing this like necessity to change. And I'm going to close up this case study by quoting someone. Actually, this is Enders, I think, yeah, Mr. Enders, who was the then leader of Airbus. And he said, "We've been thinking for a long time that our competition would be a geographic one, from China, from India, Brazil, and other places. But all of a sudden, we see there might be a competition coming from a sector that we didn't even have on our watch." And hopefully they are getting worried and they will start changing and moving forward a bit faster.
Okay, so we did think that we could talk about rapid prototyping, 3D printing, and products without talking about crowdfunding. So we're going to talk a little bit about that as our next case study. So, hands up if you've heard of Kickstarter. Keep your hand up, or put your hand up again if you've ever funded a project on Kickstarter or a similar project. I have as well. Some successful, some not so successful. So nothing really has opened up this space of creating products quite so much as crowdfunding platforms, because now anyone that's making something can get funded from anywhere. So that's really fascinating. Kickstarter started in 2009 with, I don't know if anyone noticed, they had a product, it was a t-shirt that someone was spray painting stuff onto. It wasn't successful. But it's gone on from there, and it's quickly become something that makers have really latched onto. And they have made product development more accessible to anyone. Has anyone actually run a Kickstarter project?
It's live now, I can tell you that.
Okay.
And we'll sign up before you're allowed out.
Yeah. Is it hardware?
Sorry? No, it's not. Well, it's a stove.
Oh, okay.
Oh, my friend's doing that with you.
Awesome.
Rob? Yeah, I put that on Facebook.
Q&A after the talk.
But it's not just actually about creating products, it's also about testing the market. So the thing that's really fascinating about these crowdfunding platforms is that it allows you to test your ideas out with people before you actually have to go and build it. Or maybe before you can afford to build it. And it's actually, so you're not going out creating thousands of something that is going to end up in landfill because nobody wants it. You're also engaging with your audience early on in the process, so you're starting to get that conversation going. We spoke to this guy. This is his slightly frightening Twitter profile picture.
Emily described it as Satan.
Satan, that's it now.
He's very hot.
We spoke brain, which is an Internet of Things box that tells you stuff about things, and a thermometer called Range, which you can plug into your iPhone. He talks about prototyping in lots of different ways. So he talks about rapid prototyping with bits of wood, carving bits of foam, using 3D printing techniques to see if things will work. Actually, one of the things that he said was because of the brittleness of some of the 3D printing, if he could get something to work 3D printed, he knew that when he then took it to another material, then actually it would definitely be strong enough, which is quite interesting. But we went down this conversation of Kickstarter and started to talk about actually when you're doing a Kickstarter project, what is actually your minimum viable product? And this is his quote: you start with a marketing message and you narrow that down, and that's your minimum viable product before you actually start making things. Although I'm assuming you've got some kind of prototype that you maybe a box you painted and filmed. It's very special.
It works, there's a video online.
So it's all about your message and what you tell people as a minimum viable product. And once you have that message out there, then you can start building, and you can start prototyping, and you can start tweaking and changing things with your active audience that have actually funded you and invested in your product. Does anyone see this product out there, the coolest cooler? I don't think it feels not very British. Like it's very American, maybe, or Australian. You out on the beach and near Barbie.
We call it a nesky.
Oh, okay. So this was one of the highest, or it has been, I'm not sure if it was the highest funded kind of Kickstarter project out there. They wanted $50,000 and they made 13.2 million, which is amazing. So this on a warm day, going down to the beach or wherever, you've got this. It's far from a minimum viable product, really. It's a cooler with a Bluetooth stereo and a margarita machine on the top, and it's got some wheels, and you can strap bags to it, and then it's got cutlery inside it, bits pull out, and it's basically everything you could possibly need. So it's kind of like a caravan of the cooler. Interestingly enough, actually, the first time you put the project out there, it didn't succeed. It failed, and you put it out there again. So you've got a portable party machine and stuff like that. But he talks a lot about this has so many components, this thing, and he talks a lot about the fact that he 3D printed a lot of them whilst he was prototyping. And he says 3D printers make it so easy, you can print, you can make a correction, you can test. So just with the software and a 3D printer, once you've got that, it's just the cost of plastic, electricity and time to actually prototype stuff. So this is quite a different world from the old world where you might have to have someone create a prototype mold for you, create that thing. You know, you're kind of decoupled from that whole process, you're kind of independent of those constraints that you used to have. 55 3D printed functional parts he created. And also he created them on the MakerBot. Has everyone heard of MakerBot? MakerBot was a Kickstarter project, so it starts to get quite meta at this point. You've got Kickstarter have a page dedicated to products made with MakerBot. So you've got Kickstarted product making Kickstarter products. So if you could then find a way of 3D printing something and make something else, you could just carry on in this infinite loop of making stuff. And there's a number of interesting, crazy products that MakerBot made. That one at the top is fascinating. It scrambles an egg inside the shell. And it also allows for a lot of customization and bespokeness as well. I think these headphones, they scan your ears and then give you a perfect set of headphones that's just for you. So it's allowing, as well as allowing for rapid prototyping, it's allowing products to actually be really bespoke, where it's just not something that you could do previously. I think there's about 30 products in there at the moment. I'm sure there's more that are made with MakerBot. Any 3D printing in your study?
Welding.
Welding. seen Print the Legend, it's really worth having. It talks about a number of 3D printing companies and how they're kind of race to get to the top. And two of the companies that it covers were Kickstarter projects. So it covers Medbot and it covers Formlabs. And it has a bit of an interesting story about what can happen when you have a successful Kickstarter product. So you're not actually just creating product. You're also creating a vision, you're creating a company, you're trying to create something that's sustainable. It might be a supply chain that you have as well. I had an interesting experience with a they succeeded the Kickstarter campaign, but they never sent the product out because what they found when they started manufacturing it, the quality didn't really work. So the supply chain was broken. They lost their money, I think. But what Print the Legend talks about as well, so Formlabs had so many orders that suddenly they couldn't just be the small company that they thought they could be when they set their target. They had to grow the company really quickly, and suddenly that comes with its own problems as well. There are other funding risks, so not all projects get funded. There is a stats page on Kickstarter, if anyone wants to geek out on Kickstarter stats. And I had a look in May, and 21.52% of the products in the technology category got funded. So that meant that just over 78% didn't get funded. So that's quite a lot. That never reach their target. If they don't reach their target, they don't get made, and they get made in some way. There's another really interesting stat on here that CNN published. This was about Kickstarter projects delivered on time. Doesn't really happen, I think, is the answer to that. At the time, this was the top 50 most funded projects that they were looking at. At the time, 30% of those hadn't shipped. Only 16% of those shipped on time. So it's this huge amount of issues along the way. Sometimes people underestimate what they need to build it. Sometimes supply chains, or they just don't know. But what you're not doing, some people find this difficult, is customers aren't buying something from a storefront. What they're doing is investing in the development of a product that may or may not happen. There's a really interesting story around, this was quite a strange product. It's a little bit like you can imagine a crib having like a mobile. It's a bit like a mobile that you attach your iPad to, so you can lie on your back and play with the apps or whatever. So this was a hand-free product, and somebody bought this or funded this on Kickstarter, was confused and thought they were buying it from the shop, and frustrated when it didn't turn up, and frustrated with some of the communications that came out of it as well, and sued them. So they sued one of the creators, Seth Quest, hadn't, again in his learning curve of how to set up a company, hadn't set it up as its own entity, so was liable for all that suing, and became bankrupt. So it's a lesson there. Don't do that. Set up your own entities. But obviously, failure is a good thing, right? We all learn from failure. And as I mentioned before, the cooler failed the first time round. It didn't reach its funding target, went back, took its customers with it from the first time round, and created something that was hugely successful. This is the yoga mat, which is a portable yoga mat. Anyone wants to do yoga on the move. The creator, Ryan Lane, failed Kickstarter the first time round, and saw that as actually an opportunity to iterate on that marketing message, on that minimum viable product. He reduced his funding target, but then got more. He learned things like making sure momentum wasn't lost, making sure his communication with backers was right, and created his new version of the yoga mat. So, despite all the horror stories and the fact that it can all go wrong and you can become bankrupt, very rare, what these funding platforms have done is really opened up the opportunity for people to create stuff, and what we're seeing is some really fascinating innovation in product areas. Things like smartwatches being able to take on Apple Watch. and the ability for real people like us to be able to back that and help make that happen. Couple that with 3D printing, we're away. Aims.
Yeah, so I mean that's pretty much everything we're going to talk to you about today, except for the fact that we really wanted to ask 10 people who might be interested in reading a primer for our beta version of the Minimum Bible book. Turns out Minimum Bible book is a newspaper at this point in time. We don't know if we'll ever actually get to the book stage, but we're having so much fun just talking about it, talking to people. We are not making any money from this. It's just a really wonderful way of chatting to folks and finding out cool stuff. So we've got 2 stories in this one. This is Can Drawing Save the Planet and Prototyping in Public. So we touched on 2 of those topics. We've got 10 copies. If anyone wants to commit to reading it and then giving us your feedback, we would love to hear from you straight after the talk.
We like to iterate.
We do like to iterate. We have done an alpha version of the Minimum Bible book, which was online only, just our community of people that we talk to through our blog, so it was about 100 people. And that was sort of early stage, kind of testing our content. We're going to do another talk about the actual Minimum Bible book and all the things we've learned at Agile Cambridge, if any of you go there. But yeah, if you've got any questions, now's the time. I think we've got a couple more minutes to go.
Just one thing. If anyone wants to talk to us now, at some
Oh,
point,
yes. Yeah.
and tell us their story. We're not just 3D printing and hardware is just one of the things that we found has come out of our conversations. There's lots of other exciting stuff that we're following up
Yeah,
at the moment.
one of the other things we're exploring and we'll be sort of releasing a version about seeing is like scaling companies, and then just a bunch of other things. Anything that sort of comes up that's fun and interesting and all that sort of stuff we're always looking to. You don't have to be an agile person. Yeah, any questions?
I've got a statement more about your crowdfunding. There's a guy from crowdfunding.co.uk, which is for the last 3 years, and he's actually here at the conference.
Is he?
So if anyone's interested, you'll look him up. I just met him for the last talk. So.
Cool. Do you know his name?
I hope to only ask for that because I do know it, I've just forgotten it.
Is it Robert Love? Is it Robert Love?
It's Owen Wallace.
It's Owen.
Oh, that's right, okay.
Anyone?
In a similar vein, there's a makerspace on this campus called Making Out,
Yeah,
and
yes.
printing milling machines.
We heard some good stuff about this. Yeah. We definitely will. Yeah.
I don't know if you've already heard about Lean Pub and Wikispeed.
Yes. Yeah.
So I don't know if they're already in your book or not, but they might be worth people interviewing.
Lean-Pub's very interesting. A lot of people that we've been chatting to sort of operate their Lean-Pub projects. And yeah, it's really cool stuff about taking it directly to print on demand Amazon services, which I think is cool, but I hear and have experimented with.